Imagine trying to mold clay into a shape, and suddenly the clay starts giving you life advice. Well, building a robot is a bit like that. It shapes you as much as you shape it. But why am I telling you that we should all be building robots? No, not to please Skynet or any future emergent, potentially apocalyptic AI technologies. There are a few fairly obvious reasons. The most heartening and least funny is that building robots can make you start thinking of ideas and problems as opportunities to create, improvise, and cooperate with others. Robots are pretty cool, and it's pretty cool to show off your cool robot to your friends and family. It's also a pretty decent tool to make you seem smarter than you maybe are, unless you build a lame robot, of course. If the robot you want to build is complex or big, you get the opportunity to work in a team as well. This is something a lot of us do day to day in software engineering. But honing the skills involved in teamwork can be fun when you do it in a more laid back environment than at work. The world of robotics is one of open doors. Once you start, there's a community of enthusiastic individuals that are eager to share their knowledge with you, and you can use them as playtesters and critics for your work. But first, before we get into it, who am I? As you hopefully just saw in that slide that appeared like 3 or 4 times, my name is Hyla Fourie, and I work as a software engineer at BBD Software. This does not qualify me at all to tell any of you that you should be building robots. Here's what does. I started working with robots when I was in primary school as a part of a small robotics team. We didn't even really compete in any competitions. However, this did give me the opportunity to compete in a competition in high school as a part of the robotics team there. We competed in First Lego League. The goal of the league was to be crowned the ultimate robot overlords of all under 16-year-olds in the world. Spoiler, we were not crowned as such by the time I turned 16 and needed to step away from First Lego League due to my advanced age at the time. But next year, my team was chosen to compete in the first Tech Challenge. The finals were held in Detroit at the Detroit Institute of Technology in the US, and we competed there on behalf of South Africa. Here, we destroyed the competition with our dope robot obstacle course, where people could compete for the fastest time in finishing the course. My participation in robotics when I was younger really influenced the path I took in life as well. I was sure I wanted to do medicine when I was a child with my little plastic stethoscope, but being interested in robotics and coding really threw a wrench in my life path. When the time came to choose my career path, whether I wanted to do medicine or engineering, I decided that I couldn't decide. I needed something that would compel me of one direction or the other. So I stuck to my uncertainty and decided to pick a degree combining the two fields. I got my degree in biomedical engineering and then decided to expand my knowledge of the tech world with a degree in electrical engineering. I do miss the blood and guts involved in medicine, but found the pursuit of solutions to problems most fulfilling. A feeling of fulfillment I would love to share with you all today. I want you guys to walk out of this room with an idea of how robotics can enrich your life, hone your skills, and be a platform for fun and cooperation. I know that sounds like a bit of a tagline, but I needed a tagline at some point. Let me start by telling you how the world of robotics I took part in showed me these things. First Lego League was made for kids to foster innovation and cooperation. They made robots seem fun by softening their metal edges by the round yet painful when stepped on edges of Lego blocks. The competition was not something my team ever won, again. However, I felt like sharing it with you all because it shaped my approach to problem solving very drastically, thanks to its 4 criteria of assessment. There was the robot game, a research project, the robot design, and some core values. Let's start with the robot game. The robot game is the whole reason that the competition exists. You make a robot that has to perform very specific tasks relating to the theme of the season. The tasks vary in how many points they are worth, as well as their difficulty. Consistently, though, they are all made to infuriate you with every mistake that you make. You have 5 minutes to earn as many points as you can. You do get to try twice, but your highest score is used to determine the winner of the robot game. Of course, there is a second and third place, but we don't talk about those. For the other three categories, your team has to do a presentation to a panel of judges that is oh so free of stress to a group of anxious under 16-year-old kids. First, you have to present your research project to the panel of judges. You're given 10 minutes to present 3 months of research and design on a system that you found that is a solution to a problem relating to the season's theme. That is not much time to convince anyone of anything, let alone that your idea is a good one. Next, you have to defend the design choices you made for your robot in the robot game. This usually involves a great deal of the judges instantly seeing the dumb decisions you make, and then you having to come up with a reason that isn't just because it works. We once added 3 blocks to the left side of our robot because when we attached a certain attachment, it would be weighted to the right side and fall over. Finally, you are assessed in how well you represent the competition's 7 core values. I definitely have them memorized, but I'm not going to go over every single one in detail right now. This portion of the assessment really focused on teamwork and presentation skills. The team gets assessed on how well everybody's contributions are represented in the product that you produced in your design project or in your robot. You want to show that each team member's thoughts and ideas were heard and that every member of the team can present their own contributions to a panel of judges. The judges were also interested in how you worked to improve your community. This aspect of the assessment was not really at all about how much money you could raise. They are interested in how much effort you put into improving the lives of vulnerable communities. They also wanted to spark an interest in children in how robotics can and should be used to improve lives. Here's why I'm telling you about the different criteria. The robot was important, and it was the reason the competition existed and exists still. But in the process of taking part in this competition, I learned more than just logic, coding, and design. I learned about the soft skills as well. Hard skills are very hard to use if you can't get people to listen to you. Work is stressful no matter how much fun it is, like my job. But knowing how to communicate in a team is extremely difficult. It's a vital skill that you need to be valued within a team. And there's no better way, unfortunately, to learn this skill than working in a team. First Lego League, for me, represented a low-stress environment where I could make mistakes with my soft skills without a mistake potentially ruining my future within a company or something. Okay. At this point, my notes say that you should all be confused as to what this means for you. You can't go back in time and compete in one of these competitions yourselves, nor can you compete in a competition designed for children. You can't, but here's what you can do. Start by getting your hands dirty. People tend to tinker with ideas in their minds, and especially people in tech like us. So why let this tinkering stop there? Whether you think that you could automate some part of your home routine, or that you could just come up with something cool to build, it can only be cool if you start building it. To start creating, I'm going to give you guys some steps now. You might want to start building a team if it's a big project. Other people tend to want to join in when you say you are building a robot. Trust me, there are people in this crowd who wanted to join me in building the robots for this talk. Once you have an idea and maybe some friends, if you're lucky, it's time to come up with a plan to build the robot. This could be comprehensive, or the plan can be to just wing it, but that is a type of plan. Now you can get to the fun part of this whole process. Building the robot. You are simply executing your glorious design. As someone who has built her fair share of robots and machines, at this point your plan is incredibly likely to go wrong. Luckily, many of us here in the software engineering field are familiar with agile development. When something goes wrong, you can change your plan and try again, change your plan to something completely different maybe. Now that you know how to get started, it's time to get into the juice of the matter. I took some time to build some robots to demonstrate some of the concepts I covered. Something I've been wanting to do for a while is make a toy with marbles. And what better way to show you that building something isn't hard or even something you need a specific plan for than building a machine out of wood with no code involved, is what I thought before building the machine. I started by finding some inspiration in the form of a video I saw of a marble track. As you can see, the marbles are being dropped down various chutes and then being lifted up to the top to drop down the chutes once again. Okay, now, this was my inspiration. However, right off the bat, there were a couple of things that I thought were not super necessary for me to build. What is this spinning hammer? I'm not really that sure. I don't know what the spiral is for. I'm pretty sure it serves no structural purpose. Both of these things, don't even know what they do. I'm not even going to get into the little wooden toy on the side. Obviously, I could definitely build this part as well. I think you would have to whittle it out of wood, but I didn't want to make anyone feel bad about their inferior woodworking skills. So I discarded the very intense stuff and produced a slightly simpler machine. This is what I built. And in typical demo style, it is actually broken since I dropped it. I do have a video of it working, so I'll start with that. And by working, I do mean working since I only filmed it after it was broken. I do have to press play on this, unfortunately. Oh, my mouse is missing. Nope. So as you see, I put the marble into the bottom left-hand side and then I plug it in, which I don't know why I felt the need to show. And then the motor starts spinning it, moving the device up and down. The marble moves in through the left, into a hole on the right, and then falls out on the top left-hand side. So that is what the machine is supposed to do. Here's what the machine is doing right now. Let me just get my cable. I'm very excited that you guys get to see my failure in high definition in person. Just grab a little marble that I have here in my little fanny pack. Oh, now we patiently wait. A whole lot of nothing, as you can see. Right now, the marble isn't even rolling into the device unless I tilt it to the left. Whoop. And then it'll fall out the left. Thank you, everyone. This took a lot of time. Wish I didn't waste that time. Maybe I could have built something that wasn't out of wood, which would have showcased the skill set that I actually have. So let's talk about how I created this triumph of engineering. The first thing I did was to go shopping for stuff, since that's where I could get my inspiration. I went with the knowledge that I would need some gears, some stainless steel bowls or marbles. I did not opt for those. Some wire and some wood. I had some wood lying around anyway, so that was fine. I'd also need a DC motor and something to power it with as well. So what I'm powering it with is something I found in my drawer. I have no specific specs for you, except that it outputs 12 volts DC. And then I just chopped it up and soldered it to the back pretty badly. After I went shopping, I came up with a high-level plan of how I would start putting all of this together. I decided that building the driver for the machine would be the best place to start, since I would get an idea of how this moved. Humans are prone to human error, in case you weren't aware, so even though I would try to measure everything, it was likely to be off. So building the driver was a safe way to make sure that I had the correct measurements for drilling my holes. So for the driver, I started by cutting some plexiglass in a perfect circle, as you can see, but that wasn't super important. The important part was attaching the screw about 15 millimeters away from the center of spin. This would give me a diameter for the circle of about 30 millimeters, which defines the height of the stroke of the machine. Next, I added this plexiglass shaft, we'll call it, which would move this eventually. I made it rigid for no real reason. I could have attached this to a string if I'd like, but it does give me more consistency in how everything moves. Next, I had to think about how on earth this would work. I knew that I wanted something that lifted marbles, but I wasn't sure how I would get there. So I spent some time coming up with a bunch of potential solutions and tried to balance simplicity with effectiveness. Obviously, effectiveness did not quite come through. I decided that the marble would enter the moving part of the machine at an angle, which would obviously force it into the moving part of the machine. The moving portion would then move up, and the angle would force it into the solid part on the right-hand side. It would then move down, and then the process would repeat until it fell out on the top left. It's definitely me, don't worry about it. Obviously, I had to come up with some real measurements. So there's the saying from woodworkers, measure twice, cut once. Obviously, I cut many, many times because I'm not great at cutting with a saw, as you can see from the scars on my knuckles and on the insides of my hands. But I did try my very best anyway. Often go, I thought it was just me for a second there. After going over how it moved many times in my head, I came up with a little equation that would help me come up with real life measurements. So I figured that for the difference between the holes on the left, the height difference between their centers, not that that matters, it could be from any point that's the same, would have to be 2 times the stroke, which is what we spoke about earlier, minus 2 times the height of my incline, which is odd. The height of my incline here is 2 millimeters. That works for the difference between the holes. You just divide that by 2 for the height of the hole on the right-hand side of the machine. When it came to the practicality of assembling all of this, I had many regrets. Why a marble machine, and why with such precise measurements? But I had a lot of fun trying to figure out how I could eliminate my own human error from building this. How could I drill holes at the correct spots at the correct angle with a drill and a vise, essentially? The answer was trial by fire. I had a couple of pieces of wood that I could burn through to practice drilling the holes in the correct spots with the correct angle. Eventually, I got them lined up correctly, as you can see. Here's something else important I learned while building my cute little marble toy. Most of the things I needed to build it are bizarrely hard to come by. I spent a very large portion of building my machine looking for materials that I would need to build it. I ended up having to substitute so many things that I would have liked to use with makeshift things like this plexiglass. I needed to change how the machine worked to accommodate for the fact that I couldn't get a hold of the right components. Components that I considered to be quite rudimentary. I wanted a large gear, couldn't find a large enough gear, and I wanted some basic pulleys, and the smallest pulley I could find was around about this big. This was frustrating because I felt like in building this, it was mostly roadblocks and delays. But when everything finally came together, I was incredibly happy. I would mostly describe it as relieved, though. And it made all the searching and substitutions feel worthwhile until last night at 8 o'clock. It also gave me an insight into all the reasons it's a good thing I became a software engineer and not a woodworker. So what if you don't feel confident about making something from scratch like I did in a very big lapse of my own judgment? Oh, it broke further. Let me not flick anyone in the front row with a thumbtack. Let me get this out of your view as well. It's quite ugly. So what if you don't feel confident about making something from scratch? Well, building a robot doesn't really mean you have to build the hardware and design it yourself. There are a lot of really nice kits that you can use. So companies like Raspberry Pi and Arduino have kits that you can use to build robots with code already written for them and instructions on how to put everything together. If you want, you can even buy a Lego EV3 Mindstorms kit, which is what we used for my Lego competition when I was younger. I, however, had a friend who had a kit already that was made by Waveshare for building a robot. The power, the brains behind the robot, was made by Arduino. So The robot comes with some subroutines written for it already, so the joy of the project was most certainly in building it. Compared to the marble thing, it was a joy. So let's get into it. This is the AlphaBot. This is the kit I just showed you guys. I'm gonna demo it for you. Right now, what I have on here is an obstacle avoidance subroutine, and it uses the infrared sensors over here. So unfortunately, I have only a small amount of real estate to work with, so this is going to be a quick demo. So I'm gonna put it down here, and essentially, it's just gonna try not run into things. I hope everyone can see how wonderfully this is doing. It's trying its very hardest. I'll do another run this way, just in case you missed it. I hope you enjoy my deep lunges as well. I'll practice that a little bit more as well. So, I said the joy was in building it, but the joy is in playing around with it as well. There are many subroutines on this that I won't show you right now, and for the sake of time. There's a line following subroutine. If you buy some extra sensors, you can control it via Bluetooth. There's also an infrared remote control that came with it that you can control it with, just like a normal little robot. So, as a way of learning and teaching you guys maybe, what I did after I built the robot was I added a basic program of my own to the robot's functionality. I had a look at the logic and functionality that the existing code had to see how it interacted with its various sensors, and I tried to build a program myself. Without getting too technical, I want to start all of this by telling you all a little bit about microcontrollers. Many of the robots you will build by yourself make use of microcontrollers, and I want to give you guys my sweet little crash course before I start describing the program. If you have ever wondered what the brain behind a robot is, this is it. The appeal of microcontrollers is that they are essentially miniature computers, and you can't fit an entire PC in this machine, so that's super useful. Microcontrollers have a CPU, which is the brain of the computer, the brain of the brain, if you want. It has internal memory where data and instructions are stored, and they also have input-output pins. Don't get confused by this image, it's a lot. These pins are what connect the microcontrollers to the outside world. Inputs can be sensors and switches, and outputs can be motors, LEDs, and other types of actuators. Now, looking at this graph, you might see how it's complicated to know what sensor fits in where. Yes, that's very true. So if you're building a robot from scratch, you're going to have a lot of looks at what fits in where. So now that we know what robots use in general, what does our little AlphaBot use? The AlphaBot uses an Arduino Uno Plus. Most Arduino boards can be coded in C or assembly. Now, assembly is very close to raw machine code. However, it's like solving a puzzle using toothpicks instead of your fingers. You can do that, but why would you do that? So to keep us from getting distracted by the low-level complexities of how to code what might as well be ones and zeros, I'm going to show you some of the code that made the robot go brrr. Let's try and understand how a basic program works. I use the Arduino IDE, but apparently you can use Visual Studio Code if you want to spend 2 days setting it up. When you create a .ino file to contain your code, the IDE is nice enough to give you the basics. You can set up some stuff, and you can loop through some other stuff. Now, this might be intimidating if you haven't coded before, but the code I'm about to show you makes use of classes and objects, right? Many of us here have coded before, so I hope I'm not boring you guys. So a class represents a section of code that you might want to reuse. There are many functions that you can reuse, and objects are instances of these classes. Consider classes as the script of a play, and objects as the actors who bring that play to life. The script defines the roles and dialogues, but it's up to the actors to add their own flair and humor. So, classes are like the director's plan, and objects are where the drama unfolds. So, The class that we will be using is called AlphaBot. This class is going to make interacting with our microcontroller much, much simpler. It takes care of the setup that we need for the microcontroller. Very importantly, it is defining the pins that correspond to the different motors on the robot, right? And it's very hard, like I said, to know what pin corresponds to which motor. Next, it's defining these pins as outputs. Now, that's a great deal of setup done for us already just by instantiating an object. The class also defines various useful methods that we can use. Turning left, turning right, moving forward, moving back, stopping, basic car things. Now we know what we have to work with, we can start writing our program. We can start by creating an AlphaBot object called escape vehicle at the top. Using the AlphaBot class, we can tell our escape vehicle that it should move at a specific speed without worrying about which output pins the motors for the wheels are connected to. As a side note, this value is just the strength of the voltage output to the pin. The highest voltage is 3.3 volts for this microcontroller, and the lowest is 0, obviously. The voltage is discretized into 255 steps, right? This just means that there are 255 divisions of 3.3 volts. And if I output 69 to it, it'll just move at 3.3 divided by 255 times 69. Obviously, you can set it to anything. If you've set it to 255, it will go at its fastest speed, and 0 will be no movement. Since we just have a simple program, we just need a loop. The while loop that is always true will just mean it runs forever. Classic infinite loop stuff. In this loop, we are saying that our escape vehicle, the object, should move forward. We are saying it should move forward for 3 seconds. Obviously, that is in milliseconds. And then we are saying it should turn left. Because what I'm going to do is I'm just going to make the robot go in a little bit of a circle, maybe a pentagon, depending on what surface I put it on. Okay, let me show you guys how to do that. After you have written your code, let me just, don't worry, there you go. I think the camera's on me. You just need to flash your robot, right? So what this means is there is code on this already. It's the object avoidance code that was written for it before. And now I want to put my simple program on here. So I just have to plug it in. I heard a question before I started, why is my robot on a coffee cup? This is because sometimes when you're flashing robots with wheels, they drive away. And I would like it to be plugged in while I do this. So here's the code that I just showed you guys, and I'm simply going to upload it. Now in the Arduino IDE, you need to specify where you're uploading it to, but usually it can figure that out by itself. Okay, let me take this away now. Okay, so as you can see, it's already moving, which is why we put it on the coffee cup. Okay, I don't know what I dropped, it's fine. Must be the coffee cup. Okay, it's going to move left, so I'm gonna drop it down here. Is the camera ready? Oh. Okay, there you go. And there it goes. Our first program, oh, it's going to drive into the wall. It's trying its best. Let's not judge it too harshly. Let's just put it back down and try again. It's going to drive back into the wall. Can't believe I've done this. That's fine. You guys get the idea. It's still trying to do it forever. And those are the basics of how to program a microcontroller. Well done, everyone. I'm glad you stuck with me through all of this. You guys had some great ideas, great contributions. Thank you. So, building a robot from a kit was a huge relief from the difficulties of building a machine from scratch. It was quick, easy to set up and start playing around with. Having an example of how something should work, like I did with the AlphaBot, made it much easier to recreate. So, building this program was painless. Now, the nice things about most of these robots that we can build from kits, like Arduino or Raspberry Pis, is that there are thousands of enthusiasts around the world who use these microcontrollers. So there are thousands of people posting their findings online and people you can ask. So there's a template for you to work off of. So if you're trying to imagine how to reimagine the wheel, that's a little bit of a waste of time usually. It's good to keep in mind that you can work off of other people's work. However, I do recommend not copying, not because I care about plagiarism, but I do care about plagiarism. It's just not because of that. The chances are you are building something slightly different from what someone else has built, and you have slightly different materials available to you. So use their work as inspiration, but please don't copy. With that being said, there are so many interesting sensors and displays and actuators available that readily interface with Raspberry Pis and Arduinos. So like I mentioned, this AlphaBot already has inputs available for many extra sensors like the Bluetooth interface and the infrared sensor. So I do recommend that you go and explore these sensors because for building things in the future, this will help you. The sensors and actuators in these small robots are ubiquitous. Even the most advanced robots and machinery make use of these sensors in one way or another. So, becoming familiar with them might open more doors than you might think. So, between the option of building something from absolute scratch, like the marble lifter machine, and the robot from a kit, if you are a budding robotics enthusiast, build something from a kit. It will make your life much easier and it will make you feel better about building more robots in the future. But in my opinion, the most fun you can have is building a robot in a team. If the thrill of competition and the intrigue of creating is to your fancy, I found a couple of competitions that are not for pre-adolescent children. Here are some of the competitions I found that vary from complex and expensive to beginner-friendly competitions. The competition that you want to pick is really up to you. Games is a really nice option though, since there are very many categories that you can compete in. I'm not really here to advertise robo games, otherwise they need to sponsor me. So I won't go through every single category. But interestingly enough, there is an artistic category, which is pretty cool if you want to go have a look at that. If that doesn't strike your fancy, there are various categories of robot fights, humanoid and non-humanoid fights, and many other categories to compete in. Design, modern design, AI integrated, whatever you want. But some of you guys might not be interested in the fight. If you're not interested in what robotics you can create, maybe you're interested in what robotics can do for you. Just as we are unafraid to push the limits in robot battles, we shouldn't shy away from embracing robotic advancements that can transform our daily lives. I'm sure that you can think of at least 10 tedious things in your house that you wish you didn't have to do all the time. So why not make a robot do them for you? You can make a robot that puts together the perfect morning coffee so you wake up to the smell of roasting beans. Maybe you can build a robot to clean up the bananas that Lucky left scattered around after flying his drone. Maybe you just want to stay in bed and you want a robot to open and close your curtains for you in the morning/evening. I think now you can see that these repetitive tasks can be delegated if you take some time to build systems that can do them for you. The world of agriculture is also being improved by robotic automation, with machines that are capable of farming fields with a combination of AI technology and robotics. They can make decisions for the field, like when they should be watered, what plants aren't doing well and should be removed to improve crop yield, and whether there are weeds, and they can remove them for you. The world of automation is also advancing outside of even these maybe mundane fields into the world of biomedical engineering. For tens of years, the world of medicine has been being improved by automation. Robots are making surgeries less invasive, like the Da Vinci robot, which can be used for many procedures, ranging from cardiac to urological surgeries. Anesthesia machines have been improving anesthesia for years as well. This machine has been around since the 1900s and ensures that a patient is being administered with the correct flow of anesthetic gases at the correct speeds and balance. By the way, this picture is not of an anesthetic machine. This is an anesthesia machine. I just thought that the other picture was cooler. A little bit of a gross use of robotics is patients swallowing small micro robots with cameras in them that take pictures of their digestive tracts to aid doctors in the diagnosis of certain sorry, it's just a very funny thought, of certain diseases of the intestines. Robotics permeate many aspects of life today, and robotics is likely to only become more pervasive in all aspects of living, even the way that we think. I told you all that the world of robotics can change the way that you think about solving problems. I said this because it has changed my way of approaching problems. I've been fixing things around my house since I was young, but with more success since I started becoming involved in robotics. During my final year of electrical engineering, my oven broke. Ordinarily, when stuff like this happens, you need to call out a technician or a repairman. However, at the time, this thought didn't even occur to me. I spent 15 minutes running tests on the oven and determined that the thermostat was broken since it just kept getting hotter and hotter. Of course, my potatoes continuously burning should have hinted at that, but let's not get into it. Next, I ordered a new thermostat since I determined from the thermostat's crispy appearance that it had burnt out. I waited a day and installed the new part. Just like that, I was back to baking cakes. Of course, they didn't turn out super well because, like my woodworking ability, my baking ability is not excellent. Fixing that oven would have cost me around 4,000 Rand at the time, but I only needed 60 Rand and 2 hours of my time, which was perfect for a student with no job. Maybe you guys leave this room and form a robotics team that will be a force to be reckoned with. Or maybe you'll just start building cool robots for the hell of it. If you do, I hope it helps you fix your own ovens in the future. This has been a lot, though, thus far. And if you are new to this, I may have only deterred you from building robots. I've been involved in the world of robotics for a huge portion of my life. So for me, trying to build something is always exciting because I know what to expect. The disappointment that's on the floor right now, and the highs that's on the table right now. But why should not knowing how to do something be scary at all, like our keynote speakers talked about? I found myself not knowing how to approach many of the problems that robotics posed to me, but I went ahead and tried to solve them anyway, and it changed me for what I think is the better. But maybe the doors that robotics opens will leave you spoiled for choice, and you won't know what to do next. Here's what is certain. I have a bit of a problem with buying plants. I can't seem to stop. The problem is so bad that I can't even afford to feed the family of ants that live under my fridge. Unfortunately, I'm also interested in a wide variety of different plants. And each plant tends to demand different amounts of water and attention. Keeping track of what plants need how much water and when becomes a major chore for me to complete, even though I love them so much. This is the problem. I know I can build a robotic system to take this chore off my plate, whether I automate the process of watering the plants entirely or just have sensors that tell me when they need watering. I know what solution I'm building next. How about you guys?